In college algebra, we started 2.6. We didn't go very far today. We talked about the sum of two functions. In this case, you just add like terms or combine like terms. If you're subtracting two functions, you subtract like terms. Just be careful with your minus signs because some become plus signs. Between two functions that you're multiplying, you distribute. The quotient property, that's where you're looking for common factors to cancel out. And we'll get to that eventually, not in this video. The other thing I gotta say is, how do you read this thing? So this right here is read f plus g in terms of x. Someone asked during class about what that x means, and then it dawned on me some people are thinking you're multiplying by x, but we are not multiplying by x. That notation with the parentheses, that's just the way they decided to describe combining two functions that consist of x. So like if they had y's, they would write y right there. It's just saying when x is in question, we're combining the two functions. So on number one, I just start by writing function f, and I write a plus sign, and then I write function g, and you combine like terms. I like to have the largest exponent first, so I move x squared to the front. Then I see a 2x, and I see a 1 and a negative 4, so that becomes negative 3. And that's it. That's all you do. It gets more difficult on the back of this handout, but at the very beginning, very basic. Number two, same exact idea. We're going to take it one step further, though. You write function f, plus sign, function g, and you combine like terms again. So we got x squared, 4x, and plus 2. Now it wants us to take this further. It wants us to plug in 3 into the f plus g function. So if you need to, write the function we just got above it, and you're going to plug 3 in place of x. Some people forget, or don't realize what we're plugging 3 into. We're plugging 3 into the sum of the two functions. So we end up with 9 plus 12 plus 2. And that is 23. For this next one, it is a little bit tricky. We still combine the two functions by adding like terms. So you write function f, plus sign, function g, and there is actually no work to be done. These are unlike terms. Cannot combine. If you're thinking of in terms of squaring both sides, there's not really both sides. The other side of this thing is f plus g, x. So if I square both sides, that doesn't really accomplish anything. And you can't really get 1 on one side because that's not what this is about. We're not solving it. We're just simplifying as much as we can. So you're done. That's the end. Now the domain is very tricky. So let me write something. For domain, you cannot square root a negative. So you must find values that force this is tricky. It's called the radicand, that force the radicand to be positive, that force the value under the radical to be positive. And that's a little tricky to do because it has to work for both radicals in this case. So start with one of those values under the radical, and that's x plus 3. And to force it positive, you say greater than 0. Solve for x. You subtract 3 from both sides, and you get that. Next, you take the other radicand, and you say x minus 2 greater than 0. Solve for x. And you add 2 to both sides, and you get that. Okay, now here's the hard part. Our answer is one of those, and it's the one that gives us a positive for both radicals. So, for example, 0 works for this. Right? So plug in 0 into both radicals. On the first radical, I get a positive, and that's good. Look up at the middle of the screen. For domain, you cannot square root a negative. So we checked out right there. But if I plug in a 0 on that second radical, do I get a positive? No, I get a negative. This is bad. 3 works for this one. Plug in 3 to both. That is all positive. That is the answer. It's a very confusing concept. So first off, you take the value under the radical, make it greater than 0. Solve for x, solve for x. Then you have to test numbers, plug them into the radicals. You can do that in your head if you want. And you pick the one that works for both. Let me write that. Worked for both. This takes practice, so hang in there. It's a confusing thing. All right, we took it one step further. We did 4a, and then we stopped. So on number 4a, we want to subtract function g from function f. So I copy f. I write a minus sign, and then I start a parenthesis. You can do this step in your head, but I wouldn't. You don't want to mess up a sign. So start a parenthesis and then copy function g. And then we flip the signs in the parenthesis, and we have this. Now I just combine like terms, and we're good to go. That's it. All right, we'll do the rest on Monday. See y'all later. Bye.